Alright, I believe I left off right here. So we noticed that the distance from the vertex inside the curve to the focus point is going to be 3, and outside the curve to the directrix line will also be a distance of 3. And since this one is opening left 3 here is going to be the focus point, and out here 3 is going to be the directrix line. And you can also label this. This is the line x equals 7, and the focus is going to be at 1, 2. So you can plot it and then come over and label it. Now the only thing left to do is double this distance. So again, distance itself is positive, so we're going to ignore that sign. That's what we do when we take the absolute value. So 2 times 3 is 6. We're going to go up and down 6 units. Again, looking at the sketch that we did on the side beforehand, so we don't make that mistake. If it wouldn't look right if you went any other direction. Okay, so yes, this curve should be opening to the left. That's what our parabola should look like. And our additional points are at coordinates 1, -4 and 1, 8. And that's what you would be labeling, and you're just not seeing it on the screen. Okay, so you would label that on your notes. Going on to this problem, what do you notice about this equation? Is it in the standard form for this conic section, which is truly vertex form of a parabola? And I love that because why? It tells us what the vertex is just by looking at it. We don't have to do any extra work. We're certainly not going to square this, add like terms just to get it into the old normal form where it's equal to 0 on the other side, only to go back and figure out what the vertex is by taking x equals the opposite of b over 2a. That's your x coordinate, plugging it back into the equation to find y. That's a whole lot of extra work. The beauty of the form when we get it into the correct form here is we'll know what the vertex is just by looking at it. So let's do that. We notice we have some kind of quantity of y squared, and we have 1x. So that's going to be x equals some y squared horizontal. It's going to be horizontal. So we need to move this 16 to the right side of the equation so we could subtract it. And then we need to divide each and every term in the entire equation by 8. So we're going to divide that by 8, dividing this by 8, and this term by 8. When you divide here by 8, it's not going to look too good for us. We really want to know what a is. And by the way, you would not ever divide the 1 by 8. That would defy the order of operations. So we're not going to do that. We would just consider this as a 1 times a quantity y plus 1 squared. So you can even put a 1 there if you want to, and then when you divide this one by 8, it's just going to go right here in the front. So 1 divided by 8, that's 1/8. Alright? -16 divided by 8 is -2. So now it's in the correct form for us. We do know it's horizontal. This a value is positive 1/8, so it's going to open to the right. Again, being very careful of our vertex. Oh, and by the way, come over to the side, make a little sketch. Draw a parabola that's opening to the right. Put your focus point inside. Your 2 additional points will be up and down. Your axis of symmetry will go through it horizontally. You'll have a vertical directrix line, all those little pieces, so that we don't make mistakes when we go over here to the graph. So I notice something is with y, so it's the y coordinate, and we ask ourselves, what makes that 0? -1. So the y coordinate of the vertex is going to be -1. This is as is, so that's -2. -2, -1, come over here, plot it, label it V for vertex. Draw your axis of symmetry line in there. What is its equation? You should be this quick with it now. Y equals -1. Okay. Now we got to find that distance D so we know how far to go inside the curve on this side for the focus point, outside the curve on the left side for the directrix line. So what's that formula you had to memorize? D equals 1 over 4a. A is 1/8. 1 over 4 times 1/8 is 1 over 4/8, which is 1 over 1/2. And 1 divided by 1/2 is the same thing as 2. Okay, so again, out here for 2, and this way for 2. And by the way, what's the equation of that line? X equals -4, and the focus is at 0, -1. Okay, double this distance. What's double times 2? 2 times 2? 4. So we're going to go up 4 and down 4 from the focus point. draw your curve, label your extra points, and you're done. What is it? 0, 3, and 0, negative 5. Moving on. So now, I know your notes say rewrite the equation in the standard form of a Parabola Conics section. This is my old PowerPoint, by the way, so I was calling it vertex form. It's what the students were used to in the past. So it is a vertex form, but it's also called the standard form of a parabola when we're talking about conic sections. So we look at this equation. This is actually called general form right now, or you're used to normal form, general form, equal to 0 on the other side, right? We've got all these variables on the left-hand side. So we are going to have to complete the square for x. Why do I know that? Because I've got a middle term for x. If this wasn't here, I wouldn't need to complete the square on this. I would just notice, hey, I've got one y term, and I've got an x squared. This is going to be a parabola that's some y equals x squared. So it's going to be a vertical parabola. I need to get it into this correct form so I can identify where's the vertex going to be, how would I graph all this, where would all these parts be. So again, getting back to the fact that we have this middle term, we need to complete the square on this in order to get it into the square of a binomial. I need a set of parentheses squared. So in order to do that, I'm going to complete the square. So there's different ways you can go about doing this. There's no right or wrong way. For right now, I'm just going to move the 7, the positive 7, the constant term, over to the right side of my equation. You don't necessarily have to. I'm just pushing it out of the way because I notice if I had x squared minus 10x plus 7, that is not a perfect square. So factoring that will not get me the same square of the binomial that I'm looking for. Again, you should have brushed up on your skills and reviewed how to complete the square. So I'm just going to do this for right now. I'm just putting these parentheses in here so that you understand I'm focusing in right here. And whatever I add to one side of my equation, I better remember to add it to the other side of the equation also, or else it will no longer be equivalent. So completing the square is quite easy. I have negative 10 of those x's. I need to cut them in half, so I have half on one side of my square and half on the other side. So what's negative 10 divided in half? Negative 5. You can even write it down right here. Negative 5. So what's negative 5 squared? 25. So you're adding 25 to both sides. Now, if you were to factor this, it would be x minus 5 quantity squared. This is x minus 5 times x minus 5. That was the whole reason of completing the square, so we could write it as the square of the binomial because they're exactly the same. This is what we want in our formula, our equation. So now, as I said, there's no right or wrong way. You could have moved the negative 6y to the other side if you wanted to, and then, keep the constant on the left side. It's up to you. I just did it this way. So I'm going to go ahead and subtract this entire quantity, leaving everything inside of it alone. Order of operations, you don't mess with anything inside here because we're not going to square this thing out. We'd get back to where we were over here, and that doesn't help us. So I'm just going to subtract this whole quantity because it's positive right now. So now it's negative over here. And now I'm at the point, the only thing I have to do now to solve for y is divide every single term by negative 6. So dividing that by negative 6, again, this is negative 1 out in front of this quantity. So divide that by negative 6 and you're going to get a positive 1/6 in front. Again, nothing here gets divided by 6. You can't even do that. Order of operations. It stays alone. 18 divided by negative 6 is negative 3. Now it's in the standard form of a parabola, or what we could also call vertex form of a parabola, because what's the vertex? 5, negative 3. And that's where we're going to go with the next slide. So once again, we know it's vertical. It's going to open up because that's positive. So we would draw a little sketch on the side of where all the parts are going. So we're going to identify that's what makes that 0? Positive 5. What is that? Negative 3. We're going to go over to 5, negative 3, plot our vertex, draw our axis of symmetry line, label it. It's x equals 5. Find d now. 1 over 4 times a. So 4 over 6 is the same thing as 2/3, and 1 divided by 2/3 is 3/2. So 1.5 is our distance for d. So this is going up So 1.5, this is where the focus point will be. And from here outside the curve, 1.5, that's where our directrix line will be. Again, right there for the focus point. What are the coordinates? 5, -1.5. And the directrix line looks like it's at -4.5. Y equals -4.5. Double this distance. What's 1.5 doubled? 3? Okay, go out 3 left and right. Draw your curve, label your additional points with their coordinates, and you're done. I'm moving quite fast because I know you've had this PowerPoint already. I'm just going through and explaining it. You can pause it, go back and listen to it if you need to. In this problem, all I wanted you to do is have some more practice completing the square and putting it into the correct form so you can identify what kind of parabola do you have, what direction is it going to open, where would all its parts be, what would its vertex be, things like that. So if you're looking at this problem right here, something I would write on my left-hand margin in the Cornell notes would be, we have a y squared, we have 1x. This is going to be x equals some y squared. This is going to be horizontal. Okay, we don't know if it's going to open left or right until we get it all the way done into our correct form. But because I notice I have a -2y here, I know I'm going to have to complete the square on y. I need to make this a perfect square trinomial so that I can factor it and write it as a square of a binomial. So I'm just going to move some things around, putting the constant term on the right side. I'm putting the y term next to my y squared so I can focus in on this. This is just setting it up. I don't really need parentheses around the 8x. That doesn't really need to be there. I'm just doing that to show you that I'm separating these. And I'm just looking right here. What would make this a perfect square trinomial? Cut -2 in half and you get -1. What's -1 squared? +1. 1 is what you add to both sides. So this is going to be 16 over here. When you factor this, what is it in factored form? Y minus 1 squared. Okay? So this is positive here. Move it over to the other side by subtracting it. There you go. Divide everything by 8. Again, this is -1 times that, so that's going to be -1/8. There you have it. This is a horizontal parabola. This is negative, so it's going to open to the left. So there is a little sketch of it. Opening to the left, here's your vertex, there's your focus point somewhere in there. Axis of symmetry line is horizontal also. Directrix line is vertical. Outside the curve, never, ever, ever, ever touching my parabola. It could be close, and if it is, the closer it is, you would notice that this is going to be a very wide parabola. And I'm about to stop this video and start on part 3 for the next.